Okay, what we're going to be talking about today is the Pythagorean theorem, and we introduced this a little bit the other day, and we want to do several things with the Pythagorean theorem. So if you get out your notes page, and if you'll be taking notes as we go along, first thing that I want you to know is that the Pythagorean theorem, there's three things I want you to know about it. First of all, it can only be used for right triangles. And if you'll recall that right triangles are triangles that have one 90-degree angle in those. And so the Pythagorean theorem only works for right triangles. The Pythagorean theorem is also used to find side measurements of right triangles. It has nothing to do with angle measurements. It only is for side measurements of a right triangle. So we're going to be looking to find the measurements of each side of the right triangle. And then finally, you'll have to remember what the formula is for the Pythagorean theorem. This is not a hard formula. The formula is a squared plus b squared equals c squared. And we kind of discovered that formula the other day. If you remember, we drew squares on each leg of the right triangle and found the area of each one of those by squaring the side. And adding those two squares together, it equaled the square of the longer side. So that's where we get the formula. A squared plus b squared equals c squared. And the biggest thing you want to remember about that formula is that c is the longest side. Remember, those two shorter side squares added together equaled the longer side squared. That longer side has a special name. It's called the hypotenuse. The hypotenuse is the longest side of a right triangle. It's the side that does not touch the right angle. The legs of a right triangle are the sides that are perpendicular to each other. They touch and form the right angle. So if we look here at this first example, if we identify the hypotenuse and the legs of a right triangle, if we'll just look at this example, we'll see that here is our right angle. That little square inside the triangle represents the right angle, and these two sides are perpendicular to each other and they form that right angle. So those two sides are the legs. So let's label each one of those legs. And then the third side, this side that does not touch the right angle, nowhere on that side is the right angle is touching the right angle. That third side is called the hypotenuse. So if you ever hear of a hypotenuse, all they're asking for is the longest side of a right triangle is called the hypotenuse. And in the formula, the legs are A and B, and it doesn't matter which one's which. One of those legs can be A and one of those legs can be C. The one, or B, the one that matters is the hypotenuse, and it has to be C in our formula. So if we look at this first example, this next example, they want us to identify the legs and the hypotenuse. So the only thing we have to remember is that the hypotenuse is the longest side. So 30 centimeters is the hypotenuse because it is the longest side. So let's go ahead and write that. 30 centimeters is the hypotenuse because it's the longest side. Which means that 18 and 24 centimeters definitely have to be the legs. So 18 and 24 centimeters are the legs. Okay, so what I would like for you to do at this point is to pause the video, and I want you to look at your Lesson 5 skills packet. And on Lesson 5 skills practice, I want you to, on number 3 and on number 20, so number 3 And then again on number 20 down here, I want you to identify the legs of those two triangles and what the hypotenuse of those two triangles are. So identify the legs and identify the hypotenuse of the triangles represented on number 3 and number 20. You don't need to find the missing links. We haven't done that yet. Just identify the legs and the hypotenuse. And once you get done identifying those, if you'll raise your hand, let me check those, and then you can go back and start the video again. Okay, now that we've identified what the legs and the hypotenuse are, the next thing we're going to do with the Pythagorean theorem is to prove that a triangle is a right triangle. So since the Pythagorean theorem only works in right triangles, we can use the Pythagorean theorem to decide if a triangle is a right triangle if we're not given the picture. So let's look at these examples. The first example, we're given side measurements of a triangle of 15 centimeters, 36 centimeters, and 39 centimeters. So if this is a right triangle, then the Pythagorean theorem should work. So the first thing we should do is write down our formula for the Pythagorean theorem. A squared plus b squared equals c squared. And then we're going to substitute our side lengths into the formula, remembering that the longest side, 39 centimeters, has to go in place of c. That's the only one that matters. The longest side has to go in place of c. The other two, it doesn't matter. I could put 15 for A and then 36 for B, or vice versa. Doesn't matter. So 15 squared is 225. And 36 squared rather, is 1,296. And then 39 squared, remember that means 39 times 39 is 1,521. So what I need to know at this point is 225 plus 1,296, does that equal 1,521? And if we add those two together, it does equal 1,521. So that means that this triangle, represented with the side lengths of 15 centimeters, 36 centimeters, and 39 centimeters, definitely is a right triangle. So we're going to put yes, it is a right triangle. Okay? Let's look at this second example and see if it's a right triangle or not. So on the second example, we've got side lengths of 10 centimeters, 14 centimeters, and 16 centimeters. So again, we're going to write the Pythagorean theorem formula down. A squared plus b squared equals c squared. I've got a lot of students that want to put another plus there. But remember, we added those two squares together, and that should equal the third square, the longest side square. So in this example, 16 centimeters is our longest side. So we're going to substitute 10 in place of A, 14 in place of B, and it could be the other way around. But the one that matters is that longest side. It has to be C. Then 10 times 10 is 100. 14 times 14 is 196. And 16 times 16 is 256. So we're going to find out, is 100 plus 196 equal to 256? And you guys can tell for sure that that is not. 100 plus 196 is 296, and that definitely does not equal 256. So the triangle with side lengths of 10, 14, and 16 centimeters is not a right triangle. So we're going to put no, it is not a right triangle. It might be a triangle, a different kind of triangle, but it's definitely not a right triangle. Otherwise, the Pythagorean theorem would work. So again, I want you to pause lesson 5 skills practice, and this time I want you to do number 19 and decide if that triangle is a right triangle. So determine whether the triangle with 10 yards, 15 yards, and 20 yards is a right triangle. Once you're finished, raise your hand, let me check your work, and then you can go on with the video. Okay, the next thing we're going to do is use the Pythagorean theorem to find the length of any side of a right triangle. So in this first example, we're going to find the length of the hypotenuse. And the reason I know, again, that this is the hypotenuse is because it's not touching the right angle. So that's got to be C. That's going to be our missing side this time. So we're going to start, again, by writing down, and also notice that it says round our answer to the nearest tenth. So we're going to start by writing down the Pythagorean theorem formula, a squared plus b squared equals c squared. And then with any formula, we want to substitute the information that we know. And we know the legs of the triangle are 40 and 50 centimeters. And remember, the legs are represented by a and b in our formula. So we're going to substitute 40 in place of a. So we're going to put 40 squared plus, and then in place of b, we're going to put 50. So we've got 50 squared. And that should equal c squared. Now, 40 squared is 1,600. 50 squared is 2,500. And that should equal the square on side C. So if we add those two together, we know that the square on side C, its area is 4,100. But really, that's not what we're trying to find. We're not trying to find this square over here. We're trying to find the actual measurement of just one of the sides, this side right here of side C. So we have a tool in math that will do the opposite of a square. The opposite of a square is called the square root. So we're going to take the square root of 4,100 to find what the side of each side of that square is. And that will give us the side of our right triangle, the hypotenuse of our right triangle. So the square root of 4,100 turns out to be 64.03, and there's lots of numbers after that. But remember that it says to round to the nearest tenth, so I've gone ahead and carried it out to the hundredths place so that we can round that to the nearest tenth. So the 0 is the tenths place, and I want to look at the next number, the 3, to decide, does that 0 stay the same or does it go up? And because the next number is not 5 or bigger, that 0 is going to stay the same. So the length of the hypotenuse is approximately, we really shouldn't use equal since we're rounding, it's approximately 64.0 centimeters. 64.0 centimeters. So that 4,100 was not a perfect square. In fact, it's an irrational number since it's not a perfect square, because remember, irrational numbers cannot be written as fractions. So perfect squares, we know, are irrational numbers because they give us decimals that never repeat and never end. So the square root of 4,100 is not a perfect square because we didn't get a perfect answer, a whole number answer, or a decimal that just terminates. We didn't get one of those kind of answers. That makes the square root of 4,100 irrational. So this time I'd like for you to turn to lesson 5 skills practice, and this time I want you to try number 1. I want you to find this missing side C on number 1. See if you can figure out what that measurement of side C would be. And if you need to go back and look at my example or the example that you just wrote down, then do that. As soon as you get that one finished, raise your hand, let me see it, and then you can go on with the video. Okay, in this next example, again, we're going to try to find the missing length of one of the sides of the right triangle. This time we're given sides B and C, but we're not given side A. So again, we know it's a right triangle because it was told to us in the directions. So we're going to write the Pythagorean theorem. We know we can use the Pythagorean theorem to find missing side measurements of a right triangle. So we'll go ahead and substitute the information given to us. We don't know what side A is, so we're going to leave it. But we know that side B is 24 meters. And you don't need to put the measurement on it. Just go ahead and put 24 and then square it. And we know that side C is 26 squared. So I'm going to go ahead and do in this equation what I can. I can do what 24 squared is, what 24 times 24 is, and that's 576. And then I can also do what 26 times 26 is, which is 676. And now, at this point, I can't do anything else, so I need to start doing opposite operations to solve the equation for A. So I'm going to, at this point, move my like terms together. I'm going to move 576 with 676 because those are alike. And remember, when I move them, I need to make this plus 576. I need to turn it into minus 576. When it goes across an equal sign, it becomes opposite. So what's left on this side is A squared on the left side of the equation. On the right side of the equation, I have 676 minus 576. So A squared is equal to 100. So the square on that short side of the triangle is equal to 100. But one of the sides of that square is going to be what number squared is equal to 100. You guys probably know that off the top of your head, but again, we can use the square root of 100 to figure it out. And this time the square root of 100 is a perfect square, so the answer is exactly 10. That's a rational number when we have a perfect square. If you remember, way back at the beginning of the year, we talked about rational and irrational numbers. So the square root of 100 is a rational number because it turns out to be exactly 10. So go ahead and try on your worksheet here. I want you to try to do, let's see here. I want you to try to do number 12 this time. So take a look at Lesson 5, Skills Practice, again, still the same worksheet. And this time I want you to do number 12. And I want you to find missing side A on number 12. Pause the video, try that one. When you get finished, raise your hand, let me check it, and then you can go on with the video. Okay, now what we're going to do is apply the Pythagorean theorem to solve problems involving right triangles. So if we take a look at this first example, we're given the measurements of a computer screen. It says the diagonal of the computer screen is 19 inches. If the height of the computer screen is 10 inches, find its width to the nearest inch. Now, in fact, they will call this a 19-inch computer screen. They measure televisions and computers by their diagonal lengths. I suppose that's because they want that screen to appear bigger than it is in the magazine or whatever they're trying to sell it to you in, or on television on the advertisement. So like a 60-inch television, that's really the diagonal length of that television, even though you don't watch a television diagonally. But let's go on. We're trying to find the width of this computer screen. Now remember what we know. We can kind of see the triangle here. And what we know is here's the right angle. So this 19 inches is not touching the right angle. So the 19 inches has to be side C, because it's the hypotenuse. It's the diagonal that's not touching the right angle. The other two sides have either got to be A or B. So if we go ahead and solve this problem, we're going to be using the Pythagorean theorem since we found a right triangle in this problem. So let's write the formula for the Pythagorean theorem. Then the second thing we're going to do is substitute the information that's given to us. We know that this 10 inches has to either be A or B, and it doesn't matter which one. I typically like to solve for A, but it kind of just looks a little bit neater to me, but either way is fine. You'll get the same answer. But for sure the 19 has to be C, so we're going to substitute it in place of C. So I'm going to do everything I can in this problem. I can do 10 squared, that's 100. And I can do 19 squared, which that 19 times 19 turns out to be 361. Now at this point I've got to move my like terms together. So I'm going to move 100 with 361, remembering that since it was addition over here, I've got to subtract 100 when it comes on the other side of the equal sign. So I've got A squared equals 361 minus 100. And when I subtract those, it turns out to be 261. So the square on the side, the missing side over here, if I were to draw a square off of that, that area of that square would equal 261, but that's not really what I'm trying to find. I'm trying to figure out what is the measure of that side. So since all the sides of a square are equal, the side of that square, or the missing side of our right triangle, will be what the side of one of those sides of the square is. So remember, the opposite of an exponent 2 is the square root. So we can take the square root of 261. When I take the square root of 261, it's not a perfect square, so it turns out to be 16.16. And I believe that they told us to round to the nearest tenth again here. So this is the tenths place. So this 6 that's next to it makes that 1 go up. So the side of that right triangle that was missing is approximately 16.2, and it's inches. I scroll back up to see what the measurement was. So it's 16.2 inches. And again, it's really approximate because it's not an exact, it's not a perfect square. So the square root of 261 is an irrational number because it wasn't a perfect square. Okay, let's go on to the next example. So if you'll just kind of look over here and go back up to the top of the page over on the right side, we've got another example here. It says the top part of a circular circus tent is in the shape of a cone. So the top part is in the shape of a cone. The tent has a radius of 50 feet. The distance from the top of the tent to the edge is 61 feet. How tall is the top part of the tent? Round to the nearest whole number. Now, that's a lot of information in one question, and there's not a picture drawn for us here. But so the first thing we probably want to do is draw a picture, because that's a lot of information here. So the first thing that I notice is that it's a circular circus tent. I don't know if you've ever been to the circus before, but you can kind of see the main tent is definitely circular. So let's go ahead and draw what that might look like. So it probably looks like a cylinder where it's circular tent. And then it says the top part is in the shape of a cone. So that would have a circular base. So I've got the base already as a circle. So if I just draw a cone on top of that, that's kind of what our circus tent looks like. Here's our door, and we're going into our circus tent. Now it says that the tent has a radius of 50 feet. If you remember what radius is from your other math classes, The radius is from the middle of the circle out to one of the edges of the circle. And so that radius, we know, is 50 feet. The radius is 50 feet. Then it tells us that the distance from the top of the tent to the edge is 61 feet. From the top of the tent to the edge is 61 feet. So let's draw what that might look like. So if we're at the top of the tent, that would be right here at the point, down to the edge, like that, is 61 feet. 61 feet. And what we're trying to find is how tall is the top part of the tent. How tall is the top part of the tent? So we want to know, how tall is this? Well, you can tell I just ended up making a right triangle is what happened. So we can tell that there's our right angle right in here. So we've got a right triangle now, right here. Okay, so let's go ahead and we can use the Pythagorean theorem since we have a right triangle in this drawing. We can use the Pythagorean theorem, and we want to round this time to the nearest whole number. So we'll keep that in mind when we get our answer. So let's go ahead and take a look at this. And let me scroll down a little bit so we can have some room to work here. So again, we want to use the Pythagorean theorem formula. So we've got a squared plus b squared equals c squared. And it looks like to me that the 61 is the hypotenuse because it's not touching the right angle. So I know that 61 has to go in place of c. And I can put 50 either place, A or B. Again, I kind of like to use B. So I'm going to go ahead and do what I can in this problem. And I'm going to do 50 times 50, or 50 squared, is 2,500. And then I'm going to do 61 times 61. And that is 3,721. Now that I can't do anything else, I've got to move my like terms together. And remember to make it opposite when I move anything. So that's going to be minus 2,500. So I've got a squared is equal to 3,721 minus 2,500. So a squared is equal to 1,221. So that's what the square on that side would equal, but I want to know what the side is. So the opposite again of squared is square root. So we're going to take the square root of 1,221. And the square root of 1,221 is 34, oops, I didn't have my pen on, is 34.9. They told us to round to the nearest whole number, so the nearest whole number would be there, the 4, and the next number is bigger than 5, so that's going to push that up. 34.9 is definitely closer to 35 than it is 34, so A is approximately 35 feet. A is approximately 35 feet. So that's our answer for how tall that circus tent is. It's approximately 35 feet. So at this point, again, I want you to pause the video, just try number 1, the question about the pool table. So here it is, lesson 6, problem solving page. Try number 1 here about the pool table. You might want to draw that out, what you think that would look like, and label what you know about it before you get started. And then try to find your answer. Notice that it says round to the nearest tenth on this one. And solve that problem. Once you've got it solved, raise your hand and let me check it, and then you can go on with the video. Okay, the last thing we're going to do is work with the Pythagorean theorem, is use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. You might want to insert the word find in here. Left that out, it looks like. So we're going to find the distance between 2 points on the coordinate plane. So we want to start by graphing each pair of ordered pairs, then find the distance between 2 points. And it looks like we're going to be rounding to the nearest tenth if it's necessary. So let's start by graphing our 2 points. The first point that's given to us is 2, -2. So I'm going to put, remember I start at the origin, and I'm going to go right 2 and down 2. So our first point, 2, -2, is here. Then the next point is -3, 0. So that means I'm going to start at the origin and go left 3. And then the 0 means I'm not going to go up or down at all. So that would be our 2 points. Now we're going to draw a line between those 2 points. So go ahead and draw a line between those 2 points. And you can kind of tell that is a diagonal. Mine's not very straight, but that is a diagonal line. So you can imagine if we end up making a right triangle out of this thing, that which side that's going to be. And in fact, we've made right triangles out of these before when we were trying to find slope. So let's go ahead and make a right triangle out of these. You can either go up and over, or you could go down and over and make a right triangle. Either way is fine. Now, if you recall, the slope would be the rise over the run, which would be 2 over 1, 2, 3, 4, 5 on this side. So the slope would be 2 over 5, but that's not what we're trying to find here. And by the way, it would be -2 over 5 because that line is going down instead of up. So the line's going down here. But we're not trying to find slope here. We're trying to find the actual, how long is that diagonal line. Now, a lot of students try to count the number of blocks between the points on the diagonal line, but you can never count diagonally, because remember, the diagonal is longer than any side. So a diagonal is bigger than one block, so you can't count diagonally. So, but what we can do is use our Pythagorean theorem to find how long that diagonal line is between those 2 points. So let's go ahead and write our Pythagorean theorem. A squared plus b squared equals c squared. And I would substitute in place of a and b the 2 and the 5, because those form this right angle. So they're the legs of the triangle because they make the L that makes those legs. So I'm going to put 2 in place of A, 5 in place of B, and then I'm trying to find the diagonal line C, because that one doesn't touch the right angle. So that's between those 2 points. So I'm trying to find c squared, or trying to find c really. First I have to find c squared, and then I can find c. 2 times 2 is 4, and 5 times 5 is 25. And that will equal c squared. So if I add 25 and 4, I get 29. And then so the square off of that third side is 29, but I want to know just what that third side is. So I use my tool. The opposite of squared is square root. So I want to take the square root of 29. The square root of 29. And I know it's bigger than 5, and I know it's smaller than 6. So it turns out to be 5.39 about 5.39. I had to round that. Said round to the nearest tenth. 3 is the tenths place. So C would equal approximately, again I should put approximately, 5.4. 5.4. So the length between those 2 points is approximately 5.4. So you're going to practice this on the practice worksheet, and you're going to be trying number 7 this time. So I want you to try that one, see how you do on it, and once you get it finished, again, let me check that, and then you'll be ready to practice all of this that we've learned today on your own. So 7 on Lesson 7 Skills Practice, then it'll be time for you to practice on your own. And so why don't we, for today, let's do Lesson 5 Skills Practice. And why don't you, on that page, do maybe number 2, and number 4, and then number 8, and then number 22, and then on lesson 6, the problem solving page, let's do number 2, 3, and 4. And then on lesson 7, the skills practice page, on that page, let's just try to do number 1, 2, and 8. 1, 2, and 8. So let's try those 10 problems for tonight, and we'll practice this again tomorrow.